good afternoon, everyone. So today we have the pleasure to have Matt Stensrud with us. So Matt is assistant professor at the Swiss Federal Institute of Technology in Lausanne, EPFL. And for those who don't know Matt, he has a exceptional profile since he has degrees in just 3 different disciplines, right? So mathematics, medicine, and also statistics. So he has worked as a medical doctor, and then before joining EPFL, he spent some time in Harvard as a Fulbright scholar, working with Miguel Hernan. And by the way, Miguel Hernan was the Armitage lecturer here in Cambridge back in 2019. And so, yes, with all this, we really look forward to hearing you talk about causal inference. The floor is yours, and thanks again for coming.
Thank you so much, Helen, and thank you for coming, everyone online and here in the room. My title is maybe a bit bold, but I will try to be quite concrete because we study some more concrete problems rather than this quite abstract and a bit bold title. So let's just jump right into it.
Is it not working? Did you get any batteries?
So this picture is a bit intense, I would say. This is one picture that appeared in Times Magazine a few years ago, so in 2020, and it's meant to illustrate the opioid crisis and epidemic in the US, which has been a massive problem. So I can back that up with some numbers. This we'll touch a bit on them, but this is a bit of a motivation. So here you see death per 100,000 in the US, and you can see how those deaths, which are attributed to opioids, have dramatically increased, and specifically here, those attributed to other synthetic opioids. And we know the crisis with Purdue Pharma and how doctors were incentivized to prescribe opioids to a lot of patients, which might even not have needed them. So this is a public health concern. But my talk today is about biostatistics and methodology, but we should keep this example in mind, and I'll also touch on it in our data analysis. So here's an epidemiologic paper that asks a specific question. And the question they ask is the following. They admit that chronic pain is a leading cause of disability worldwide, and they also see that chronic pain is associated with using opioids. So their question is, what is, they use kind of a bit of, what should I say, diffuse terms here, and we'll try to make them precise, but what is the causal link between chronic pain, prescriptions of opioids, and mortality? And what they want to study somehow, and that's how they summarize their effect, is how is the effect of chronic pain on mortality somehow mediated by the use of opioids. Okay, and if we go, we'll go more into this article, but their parameter of interest is something called the population indirect effect. Okay, so let's try to be a bit more precise about this thing, but before we do that, I'll raise some more philosophical concerns. So here they describe this as the effect of chronic pain. So in chronic pain, increase the risk of all-cause mortality through opioid prescriptions. But there is a bit of a concern from a very practical view here, is that chronic pain itself does not seem to be easily intervenable, because if it is chronic, by definition, how do we go in and intervene on it? How do we remove the chronic pain? We don't know really why and how they have this kind of thing. Maybe we know why, but we don't really know how to intervene on it. Okay. And this seems to violate some of these principles, and they're principles, they shouldn't be elevated as truth. But one principle in causal inference that many follow, and I'm partial to the idea that when we talk about causal inference, we should have some idea about how to manipulate the cause or manipulate the exposure or the treatment. And in this case, this is not easy with chronic pain. Okay. And another issue, if you just think of this from a high level, is that if you're interested in the effect, so suppose we accept the notion of the effect of chronic pain on mortality, say through opioids, we have the hunch that there might be a lot of confounding here, and especially unmeasured confounding, because the reason why you have chronic pain may be strongly associated also with mortality. I mean, I may have chronic pain due to cancer. I may have chronic pain to some other kind of disability that might cause my outcome. We may be lucky and measure it, but sometimes we don't, okay? And if you take this to another higher, like abstract level, and we talk a lot about reproducibility crisis here, and I would say that from a causal inference perspective, both of these concerns really are related to reproducibility more broadly. So if we believe that there is unmeasured confounding, if we use some covariates in one study and some maybe the same or similar ones in another, how should we ever believe that we even target the same parameter? And how could we even reproduce these studies if we can't even intervene? So the gold standard for reproducing some observational evidence would be to do, at least in principle, some kind of experiment, a randomized trial. If we don't know how to intervene on that variable, how could we even do it, even in principle? So this seems to be two concerns we have in the back of our mind, and try to mitigate some of these concerns. I will study another parameter and discuss how we can actually identify and estimate these parameters from data. And in order to do that, I'll introduce some very simple notation. So essentially what we need here is a binary treatment. So suppose a binary exposure denoted chronic pain at some baseline, okay? When patients are recruited or their pain status is recorded in some kind of registry. And we have the mediator here is opioid use. And the outcome of interest is mortality. Okay. I suppose also that we measured some baseline covariates. In this setting, these baseline covariates were age, the sex at birth, previous disease history, and socioeconomic status. And we would still believe that there could be other common causes that we don't really know of. Here it's actually that there's M, there's about having chronic pain, so there should be A, and the outcome of death. For the presentation we are having right now, even though if you're not totally familiar with causal graphs and use them in your daily life and daily research, it's sufficient to think about this as a picture depicting which variable exerts direct effects on other variables. So in this setting, I said that there could be unmeasured common causes, so U's, that are causes of chronic pain A and mortality Y. And chronic pain might affect whether or not you get opioids, M, and it might also directly affect mortality. But there may also be other common causes of these three variables. Some of them we hope to measure, but there could also be some unmeasured common causes to use here.
Is it important that U is not a direct cause of M?
Yes, it is. For the results I will derive, they are. And let's pause with that because this is an important question and arguably possibly a limitation. So one thing to say is that M is actually the use of opioids. So using opioids is something that's like some kind of human action. Presumably the opioids, and we'll get back to that, should be prescribed by a doctor, okay? So in that sense, the doctor should have some argument for why they prescribe opioids. They should be recorded in some kind of registry. If it is recorded in some kind of registry, it should be possible to obtain these variable L's that causes opioid use. On the other hand, chronic pain is a biological process. I don't really measure all causes of chronic pain in this world, so having unmeasured common causes of A and Y seems to be even more of a practical concern than the U to M arrow. But you're completely right. I assume that those are not there, and they might be. Okay. Let's go further. So this is the graphical structure. And now I will try to motivate like another type of question, and you may agree or disagree whether or not you think that is the appropriate question. I think it is, but I think we can discuss it. So in order to motivate some kind of policy relevant parameter that could affect policies, say in the US after or during the opioid crisis, it's the question is the following. So the patient comes in, they have some kind of symptoms. One of them may be chronic pain, maybe not. And the question the doctor should give advice about and possibly prescribe drugs because of is, should the patient have opioids because of their symptoms? And we had an arrow from A to M. So from having chronic pain to taking opioids. Okay. So the doctor's decision, so prescription of opioids, seems to be some kind of function of whether or not you have chronic pain. But now CDC, so the Center of Disease Control in the US, has made a statement, it's in fact some years ago now, where they say that chronic pain should no longer be used to determine opioid assignments. So that's like their advice, so to speak. So we can think about that as some kind of modified policy where the doctor, when prescribing opiates, are not allowed to use the chronic pain status as an argument. So suppose two patients come in and they have exactly the same symptoms in all kind of other aspects, same, say, cancer diagnosis, same previous disease history and all, and same socioeconomic status. And yeah, they're similar, but one had chronic pain, the other hadn't, okay? Then that chronic pain status shouldn't change whether or not they get opioids. That's essentially how I interpret this, okay? But what is the important thing here? In order to conceptualize the intervention here on the doctor's perception on chronic pain and how the doctor uses chronic pain to make decisions, we don't need to intervene on chronic pain. Two patients come in, one have chronic pain and the other hasn't. We're not having the ambition that we remove the chronic pain. We're just saying we force now the doctor to make the same decisions in these two individuals. And that you could do with some kind of policy or make them go through some kind of training program and something that is actually possible to implement. Okay? So we are not intervening on chronic pain, but we are intervening on the doctor's perception of chronic pain. We can think about it that way, or how the doctor uses chronic pain. And of course, in the observed data, we have a data set where the doctor has recorded that the patient has chronic pain. So there's a one-to-one status between the patient's reported chronic pain and the doctor's perception. So these are exactly, they're deterministically related in the observed data. But I'll make a point about that because I really want to study the graphical structure with that determinism. So I started with this graph, but now my graph looks like this. Okay? And what does the bold arrow mean? It means that there is some kind of determinism. So this is not a formal graphical notion to have these bold arrows, but to me, that's just a way of indicating to you that there is a determinism. So if you want to go into the graphical modeling theory, determinism are kind of a pain because it means that these general theories and theorem of completeness of identification conditions are not, they're not sound and complete in those settings. They're still sound, but not. Okay. But what is the key hallmark of the graph we are having here? Well, there's one thing that I want to point out. The doctor's perception of chronic pain, let's call that AM, only affects the outcome Y through opioid prescription. And why is that important? So when the doctor sees that a patient has chronic pain, the fact that the doctor sees that can only affect the patient's mortality by whether or not the doctor prescribes pain medication. It doesn't affect the biology of the patient. So there could be all other causes of other aspects of chronic pain that relates to mortality of the patients, but this is a particular path. This is an exclusion restriction, and those of you, and I know many in this department have worked on the instrumental variables, this is similar. There's an exclusion restriction there. But if you look more closely at this, we'll see that it's quite an instrumental variable setting, but it's related. Okay. So in order to formalize a bit what we are looking after here and stating in mathematical notation what our parameter of interest is, so what is our effect or estimate, so we will introduce some counterfactuals. So we could have introduced these kind of counterfactuals. So the outcome, had we possibly, contrary to fact, intervened on A, chronic pain. But I would argue again that that's not clearly defined because we don't really know how to intervene on chronic pain. On the other hand, we could look at the following outcome too, which is, would the patient be dead or alive? Had we possibly, contrary to fact, intervened on the doctor's perception of the pain? So we mask for the doctor that the patient had chronic pain and see what kind of decisions the doctor will make to this patient, what they would prescribe of opioids, say, and then look whether or not the patient is dead or alive. And I would argue that that's well defined. Okay, and then we can look at this particular contrast. So what is this contrast saying? So let's start on the right side because it's easy. So this is just the observed, this is the outcome mortality, the expected mortality, say after 5 years in the observed data. So that just means how many people would we expect to die in this world when the current policy is implemented? On the left-hand side, we could say how many individuals would we expect to die if the doctors are not allowed to use chronic pain as an argument for prescribing opioids. But otherwise, they would then, and it's more than that, it's saying they should prescribe opioids as if all the patients did not have chronic pain. Okay?
Sorry, I don't. Why would a doctor give opioids if a patient hasn't got?
Because they have acute pain.
Okay.
For example, a reason for getting it is after being after surgery, they have been through an operation and they will get opioids. And some patients will, and some patients won't, and they will have that, say, for a week or certain days, but then they should gradually step down the treatment. But if they say it goes on and on and on, you should not use that as prescribing it. Or they have some other acute pain, doesn't need to be surgery, it could be some kind of other injury or something that makes you needing it for some other reason. Yeah.
A bit confused. If we set little am to 1, that still be the doctor not using the patient's chronic pain.
It will, and it would be analogous to the fact that for, say, any mediation estimates, you could look at the natural direct effect when you put the other one to 0 and 1. So this would be a policy where everybody get opioids as if they had chronic pain in the observed data. So it would likely prescribe more opioids if you believe that it was used to prescribe opioids in the data. So here, so there are 2 parameters, both of them. So both, if I put it to 1, it would also be a policy where you're totally agnostic to the chronic pain, but you just make the decision as if they had it in the observed data. And now you do it as if they didn't have it. So here it is in words. How many lives would we say if the doctor did not consider chronic pain status? So they said essentially they didn't have chronic pain. Would I then prescribe opioids to this person? Maybe yes or not. And if we put it to 1, it would be if they had. Okay, but the key idea is that we would put it to 0 here because we don't want to do that. So this is not unique to my very special setting with chronic pain. So let's take another setting. So CV whitening. So this is very hot in the intersection between data science, law, also causal inference, and this algorithmic fairness debates that are going on. Okay, so this picture is meant to illustrate CV whitening, which is this known fact that using written information on resumes can be used to discriminate against skin color, gender, and other things when making decisions about who's getting a job or not. Okay, so let's align that a bit with our setting. So suppose A denotes rates. Okay. And I don't think in many of these fairness settings, we are really interested in interventions on race. So I think that is a problem with a bit of this literature. I don't think we want to intervene on race in these settings. I think we want to acknowledge race and then make fair decisions based on race. And racism can occur in very many ways. And this is just one specific way it can occur in. So I'm not saying that we are solving any problems about racism, broadly speaking, but this is just a particular way that there could be racism. And that could appear in the following sense that by using, say, the picture on the CV or the name written on the CV, people can infer race or infer a probable race. And but we can easily intervene on that in principle. We could put in a new picture, as my picture illustrates. We could put in a new picture on the CV giving a different skin color or give different gender and so forth. And we could think about the possible scenario. Would this person be invited to an interview? So let's that be the mediator M. Had I intervened and removed and switched the picture somehow, leaving all the other things to say. And then we could further look on, would that let them get the job? So that could be the final outcome Y in the end. So again, we could be interested in these kind of interventions where AM denotes this inferred race. And in fact, they're doing these experiments. These have been done in sociology and in economics, where they have swapped names and swapped images on CVs. And this is precisely precisely fit into the same estimate framework. So in the observed data again, we would have this determinism between the actual race and the race inferred from the CV, if they had the picture of those CVs. So what I will call AM is an intervening variable, because, and I just had to come up with a name, and I call it an intervening variable because it's arguably intervenable, but it's related to some kind of other exposure A that may not be intervenable. And these two are deterministically related in the observed data, at least in the data structures here before doing interventions. But we can in principle think about an intervention on one component of it. AM. Okay. So all I've done so far is quite wordy. I mean, you've not seen any statistics, and you've not even seen any identification argument. It's just about translating questions into something arguably a bit more formal. So these estimates, these parameters, or here just expectations with respect to some counterfactuals or interventions. But let's now go further, because after all, I also want to do some statistics. So let's see how we can study these estimates from data. One thing is just to define them, but can we actually identify them and subsequently estimate them? Okay. So I argued that this is a structure. This is the same as before. And we have this possible unmeasured confounder here. So what do we do? Well, the first thing I will just do is to assume something I would say is fairly uncontroversial. So first, I already claimed that these interventions are somehow well defined, that we could possibly do them. But we would also have some, I'm stating them informally here, and we can go into the appendix slides later on if you want to see them. But I also need some positivity assumption. And this is positivity assumption is just an assumption about the observed data. So just an assumption about the conditional probability of observing A and M given some covariates L. That's all in the observed data. Meaning that I need to observe some individuals having a particular, in our chronic pain example, getting opioids and having a particular chronic pain status that need to be observed for all values of measured covariates. Okay. And I also need the following no unmeasured confounding assumption, which is precisely related to the question I received earlier, which there could be no common causes of M and Y. And I didn't write it here, but I should have. There could be no common causes of A and M. But of A and Y, there could be common causes. Okay. Okay, so this is a more formal presentation of these assumptions. We can just state them, and for many of you, this is easier, but I didn't know if there were a mixed audience here, but I'm saying exactly the same things. Okay, so here is an interesting fact, like under these assumptions, so even with the U, I can show, and I can show you the proof. I'm not going to go through it here, but we can show that this parameter is identified by this particular formula of observed variables. So for you, by just looking at it, it may not tell you a lot. If you're very deeply into causal inference, you may see that this identification result is actually the front door formula. Okay? So this is in some sense interesting. First of all, it is a celebrated identification result. So some people in the room have even contributed to that. I see David is there, and Julia Pearl first presented this front door formula, but by epidemiologists, it's been kind of some sarcasm around this result. So I think it is a beautiful identification result, and it can be done in different ways where you don't need the strong assumptions that Pearl actually needed for identifying them. But by epidemiologists, as illustrated by this Twitter discussion led by a famous British epidemiologist, George Davis Smith, who's very skeptical. He likes IVs a lot, but is very, very, very skeptical about front door variables. So he would say the following: there's no examples. There's no examples where the front door assumptions really hold. So here you can see, here we asked Julia Pearl and Maria Gilmore, so an epidemiologist and a computer scientist, just give me one example that satisfies the front door criterion. And they go on and they can't really find anyone. And then Maria says, call it out to a Twitter challenge. Can anyone come up with any? And yeah, there have been written some papers where they claim to have them, and I haven't been convinced yet. Okay, but maybe this example isn't too bad. So I should say, if you go back to the graph, so I go a little bit back, the front door condition does not hold for the original variable A here. So if you want to build intuition, why I can use the front door formula here is that for this new variable that we introduced, we do have the front door formula holding, in the sense that AM does not cause Y, but we have this unmeasured problematic confounding structure between AM and U, because AM is deterministically related to A. So this is just trying to build some intuition why this is, by introducing this new variable, by extending the original graph, we actually have something that seems to satisfy the front door criterion. So therefore, it may not be that surprising that actually our identification result is precisely the front door formula. And the only intervention we need, so in Pearl's original proof of the front door formula, you also need to hypothesize an intervention on M. In our setting, we don't even need that. So we only have an intervention on this intervening variable AM, which is the only thing I believe we can intervene on. Okay. So now we have an identification result. So let's see how we can estimate. And I'll do this from a more of a high level summary, because the first thing you should notice is that the front door formula has been out there for a long time. And people have already come up with estimators of the front door formula. So since our parameter is just identified with the front door formula, we can just use any of the existing estimators. Okay? But one problem with at least the semi-parametric efficient estimators of the front door formula that's been out there so far is that they're not sample bounded. Okay, so if your parameter of interest is bounded, suppose it's without loss of generality is between 0 and 1, then the current semi-parametric estimators, they're not sample bounded. So they may give us point estimates that are outside of 0 and 1. And in finite sample, that's kind of concerning. I mean, if you want analogies, it's like fitting an additive hazards model, right? You can get negative hazards, and that seems to be, well, we have the hunch that that's inefficient, and our simulations show that that's quite inefficient, at least in finite samples. So we tried to come up with a new one, and this is work done in collaboration, I should say, with Lan Wen, who used to be Sean Siemens' PhD student in this very building, and Aaron Sarvet, my current postdoc at EPFL. So by rewriting the front door formula as a weighted average of a traditional mediation estimate and just an average treatment effect, a weighted version of those things, we can easily come up, or not easily, kind of, it's just some semi-dirty expressions, but it's not difficult math to come up with a parameterization that ensures sample boundedness. And the models we need to fit is a model for the propensity score. So that's the model higher up here. And we also need to fit the model for the conditional outcome mean, given in our setting opioid use, baseline covariates, and chronic pain status. And we also need to estimate the marginalized version of this thing, where we marginalize out opioid use. Okay, and then we get certain robustness properties. So it's a multiple robustness properties where we essentially need 3 out of 4 models. Okay. So let's now go back to the example, because I started with an example of chronic pain, and now we use a data set, a fairly large data set with 12,000 individuals from the US. It's an observational survey where chronic pain status, opioid prescriptions, mortality, and certain baseline covariates, including age, sex, as I said, and previous disease history and socioeconomic status was collected. And using those data, we implemented our estimator, I should say, in a very simple way. So since this is a semi-parametric efficient estimator, we could use much more flexible models in order to estimate the nuisance parameters there. We did it for the sake of illustration just by a logistic regression model. We should extend that. This is unpublished work, not even on arXiv, so that will come. But just for the sake of the argument, we could estimate this difference to be rather small. So this is the estimated difference in 5 years mortality had we implemented this new policy. And this is not a large effect, which could just say, and related to Sean's questions there in the beginning as well, maybe, well, first of all, they may get opioids for other things, but maybe the number of people who really got opioids because of chronic pain was quite small. So maybe that doesn't change that much in the long run. I should also say that these data were collected before the large opioid crisis in the US. So look at the years we have here. So whether or not this is really representative for the actual epidemic, that's another question, but the same methods could be used. Okay. So what have we done? Before I go into the last part of the talk, we have some new results on an average causal effect. So this is not a mediation estimate in the sense that I only considered the average causal effect of this intervening variable versus the observed policy. Okay. And this is identified even in the presence of some kind of unmeasured confounding. And I try to motivate this average causal effect by these intervening variables that are deterministically related to something we can't intervene on, or maybe not our primary interest is to intervene on that, such as race or chronic pain. And we also defined kind of an independent contribution, but our identification formula is the front door formula, and we have a new semi-parametric estimator of this one, which is related to privilege. This work will be on arXiv soon. So now I will continue and put this a bit in a broader perspective, and this will be more philosophical and up to debate. So we all know that causal inference research is blooming at the moment. So this is a proof of principle. Here we have 3 men that won the Nobel in economics in 2021 for great works, in particular on instrumental variables. We had the Rousseau Prize of Statistics last year, nominated to these eminent 5 scientists. And Pearl seems to win computer science prize every second year. So it's no doubt that this is popular at the moment, and I think that's overall is a good thing. It gives us a lot of new tools and methodology, but when everything grows, there's certain things that we should also be careful about. And I think that I have some concerns about certain types of errors occurring in the causal inference literature at the moment, which is the fact that I tried to back this up, and this is a work led by Aaron Sarvet, who's a postdoc in my group in Lausanne, and a brilliant researcher, that we seem to see that when people write about these parameters, they seem to mistakenly interpret one parameter as another. Okay. And I think we often also see that it's inconvenient to design a causal parameter based on their statistical properties, not necessarily based on their correspondence to a scientific question. And this is related to something called type 3 error by, I think, Sharon Swartz in the more sociological, epidemiological literature, saying that sometimes they're designed to have nice properties. We get the nice answer, but it's not to the right question. Okay, so let me try to back this up a bit. So we tried to formalize this into this definition of identity slippage, where identity is somehow related to identification. So we can give it a more technical definition, which we will do in a manuscript, but the intuition is more important. So it's essentially that when one causal parameter is mistakenly interpreted as another. Okay, so let's just take a very vanilla example. Okay, this sounds like boring because association is not causation. Everybody heard in their first stats course, but the error is present in a lot of applied analysis still, but we'll more use it here as a stepping stone to something more interesting. So, for example, if you look at the AMA's manual style, so that's essentially JAMAs, like Journal American Medical Association style. They say residual confounding is avoidable, and in observational studies, we should therefore just target an associational parameter, and we should avoid causal language. But then we look at the paper from last year when we wrote up this, and we say they do this in the whole paper. They want this kind of language, but then in the conclusion, they would say something like, and this is a comparison about two stroke medications for acute stroke, and they would say that the one drug is as safe as the other for the treatment of acute ischemic stroke. So if that's not the causal statement, what does safe then really mean? Okay, so this is a case of wrongly interpreting the association as causation. So we know about this example. Okay, but the irony is that this is not like just happening in the clinical literature where people may not be experts in this and they may think they have more important things to care about than actually just the language, but it also appears in our literature. So I think the epidemiological examples I said first, where they concluded about the effect of opioid prescriptions, which was the title, on mortality, I think they did not mean to intervene on chronic pain. They wanted to intervene on opioid prescriptions in that epidemiological study. And in the effect of race and gender in certain fairness settings, I don't think they really want to intervene on race, but they want to not have discrimination with respect to race. And one particular type of discrimination is by disregarding people because of their skin color in the CV. And then I think also ironically is that Pearl's motivation for studying natural direct and indirect effects, I arguably think has exactly the same problem. Okay, and to back up the last one a little bit, so when Pearl, so this is a famous example, it's not mine, it's by Jamie Robinson and Thomas Richardson, and he talk about the effect of smoking cessation on myocardial infarction mediated by blood pressure. So Pearl accordingly has a claim that he wants to study this effect of smoking cessation mediated through blood pressure. Okay, and when faced with the public health, so I don't know if this is exactly Pearl's word, by the way, so this is a disclaimer, but when this was faced with like some public health, why these parameters of public health relevance, he would say something like, and this is rephrased from Thomas Richardson and Jamie Robinson's article, that suppose we could make a completely new type of cigarette or new type of tobacco, which we can remove the nicotine component from, that only included the other parts of the tobacco, or vice versa. We could create a cigarette that only includes nicotine, but not all the other harmful parts of tobacco. And by the way, that's exactly what the vapor is, right? I mean, it's nicotine diluted in some kind of liquid and that you breathe in without having the other parts of the tobacco. But the point is that this kind of intervention does not involve any intervention on the blood pressure at all. It's a modified version of the original treatment A. It's a modified version of the cigarette, okay? So even this could be seen as an interpretational error where Pearl motivates an intervention on the mediator by telling a story about an intervention on the treatment, a different type of treatment. And we'll have a paper up where we come up with certain more of these conceptual examples. So some to conclude that more high-level discussion there is that I think it's important that we choose the estimates, and this makes causal inference rich in some ways, that the parameter of interest needs to be chosen on a case-by-case basis, which means that we can't give this one-size-fits-all description to these things. And that is it's bad news in the sense that we need to think. It's good news, it's that it sharpens our formulation of the research question and also sharpens our critical thinking about what is a good parameter. And this is my opinion about these things, is that the estimates that turn out to be practically useful seem to be estimates that are defined in some observable set of the population at least. So we could identify the population where we're studying these effects, and at least in principle, they could be falsified in a future experiment. So I would like to thank Lan Wen, and Aaron Sarvet, who have both been instrumental in this work. Lan is now at Waterloo in Canada, and Aaron is working with me. Thank you very much.
Thank you very much, Matt. Great talk, very interesting perspectives. It was very good to hear. So are there any questions for Matt?
Yeah, excellent talk. Thank you. I want to ask about how they measure the chronic pain. So is it the yes or no, or there can be degrees that clinician can say, well, in this case, and how can that affect this?
So this is true. In this case, it was on a scale, and a pain scale. And they defined a binary cutoff in the original study on this pain scale. And I must admit that I don't really remember what the cutoff is, but it was a binarizing of something that's definitely not binary.
But in any case, the association will still be, the clinician will make a decision based, the scale will affect the decision.
Yeah.
The scale will also affect the probability of death, I imagine.
Yeah.
But not, yeah, but still.
Maybe not as a binary variable. Yeah. But although our results, we need to be a bit careful because this binarization was a bit important for some of the results I made there.
In the example with job application CVs,
Yeah.
your estimate was aiming at basically people who are not white pretending they are white, right? So
That could be one way of doing it. Yeah.
yes,
Making everybody white on the CV.
yes. I was wondering the intervention you would expect, or I would have expected anyways, was more a different one. So not comparing if everybody was white to the current outcomes,
Yeah.
but if race just didn't exist, so the person assessing the jobs couldn't see what kind of race it is. So no picture, no name, no nothing.
Yes.
Do you think that would, well, affect the identification result?
Yeah, I wouldn't be able to do that. That would be something I don't have because I have no observations in the data intuitively where I don't know the race. So I would not be able to do that. I would only be able to do it where everybody is set to a particular observed race. So that's impossible. One thing one could do is suppose one category is white and the other one is black, very simplistically. We could look at the effect had everybody been black and had everybody been white and see if it's a big difference between those two, which is related to the other question where we set this AM to 100. But saying completely mask it, we can't do. Which is what they do in the experiments.
I have a related question about the opioid, but I think it's similar. It's also related to what I asked earlier about your counterfactual setting AM equal to 0.
Yeah.
So if now we implement the new CDC policy that doctors are not allowed to use chronic pain in their decision of prescribing opioids, then which of these estimates corresponds to the effect of that policy?
So this is interesting. I think that would be what CDC says. So if the CDC say disregard it, you should not, if they have it.
What does that exactly mean?
It means, okay, so this is up to our interpretation, but it could be saying, if you said it very explicitly, say, how would you have treated this individual if they said they had no chronic pain? That's the one we can study. But we could not say, would you have treated this person if I didn't know if they're chronic pain? So these are subtly different because the decision maker, it's actually 3 categories, like I don't know, yes, no. And we can only do yes, no, and not that I don't know. And I think this is related a bit to placebo effect, like placebo control trials. In a vaccine trial, what you later on is very different from what you see in the trial where it's blinded because I changed my behavior after getting the vaccine. You don't do that in the trial. So it's basically the same thing that in the trial you will get a different estimate than in the data.
Thanks for the really nice talk. I suppose with that chronic pain example, it's very interesting to look at death. But I suppose if you're extending the life of some people who don't die due to being prescribed opioids, are they potentially living, like, are the opioids are presumably having some other effect on their chronic pain and their experience, the kind of quality of life?
Yeah, so we should, I agree. I mean, quality of life or quality of adjusted life here, so something like that. It's
exactly
better centered out.
It's not something that's-
This was and if this was a very serious application, we would definitely do this. Like the honest answer is this is also an application was used to that triggered the methodological thinking, and we used the data they had done in the original study. But I think it could be used to do serious studies like this, and then I would definitely agree with you.
Thanks. You presented a formula for the estimand.
Yeah.
And you said this is like criterion.
Yes.
So is it different in front?
No, it's identical.
Okay.
It's the front door formula.
Right.
Yeah. But we use, I mean, or this was Lan's idea, so I said we do it in our paper, but Lan rewrote it in a nice way that enabled us to come up with some nice estimators. Yeah. But that's why we could just use existing results on the front door formula to estimate it. So in that sense, it's not. Yeah. But what they did in the epidemiological study was not using we get different numbers because we use a different estimator. But if you want, I can show you the influence function of it. But I don't think it will tell us a lot. But it's just, yeah.
On that, you mentioned that previous estimators were not sample bounded, yours are, but do they have the same influence function?
Yeah. So it's the same. So actually, we're just rewriting their influence function. And then we have to estimate 4 terms. They had to estimate 3, right? So we pay a price because we have to estimate 1 more term, but we get sample boundedness. But when we consider binary outcomes or survival outcomes, as in this setting, we have some simulation showing that, which is unsurprising, that not having sample boundedness can lead to really bad performance in finite samples. But yeah, these are special cases. I mean,
this price you mentioned, this is just a price in the amount of work that the statistician has to do, not a price in terms of increasing the risk of model misspecification.
Yeah, we do have a high risk of model specification, but it's a bit of philosophical because it involves the same variables. But since we don't have, we need 3 out of 4, and they need 2 out of 3 models. So we do have a high risk of parametric model misspecification.
But no worse than the existing approach.
Yeah, arguably a bit worse, but their finite sample properties may be much worse than ours. So I would rather say to the decision maker, try both or do the one you're most confident in. But how many people do survival analysis without using a sample bounded estimator somehow? Like they rather seem to prefer a Cox model over another model in order to get that. And I feel it's a bit of a similar practical concern. Like there's a reason why, I mean, as much as I like additive hazard models because they're nice to work with, how many use them in practice? But they're more flexible because you can easily have a time varying effect in them than in a Cox model. So I view it in the same way. That's what we want, and you have to pay that price. Yeah.
So the front door formula here, it sort of has a similar interpretation, isn't it? Because basically your AM effect is not confounded, MY is not confounded. So you multiply them.
You're completely right.
In this way. So because you identify this indirect effect, whereas in the usual application, you assume no unmeasured confounder. So, but there needs to be no direct effect. So you identify the total effect.
And that's why we also compare it to the observed parameter somehow, right? It's not usually an ATE is like under intervention A equals 1 or just A equals 0. Here we just compare it to the observed. And then this intuition is that then this arrow here is just the same in both settings. So this is different. So this has also been done by this population there's a JRSSB paper by Eric Chetkin and Fulcher, where they have done very similar things with a mediation type of estimate. But the interpretation is not clear to me in their paper. And they also, their paper was the one that gave the other semi-parametric estimator. But you're right. Like now, since there's a determinism here, let's just blur our eyes and think about this arrow as, you can't just adjust for A, so there's unmeasured confounding because of the determinism. There's no effect here on AM and Y, but then it's just front door.
Does this extend to other, like a general pathwise specific effect kind of?
Yeah, so Lan and I are working on it, but this is not even out. But we have an idea about time varying structures here. But we wanted to have I think we have an example now, but we want to have also back it up with something where it's somehow plausible. Yeah. We have some, the idea is some blood pressure treatments, which should only reduce blood pressure. So we have a similar structure.
So I remember Elias Pizzer had this work on sort of identification of pathwise direct effects with these kind of setting with unmeasured confounders. I can't remember what the result they have.
No, I think
algorithm, or maybe is this covered by that? Or?
I think he's on this other GRSSP paper, so he certainly can identify. He knows about identifying stuff like this. Okay. I'm not sure, or I think you can't just put it in the general ID algorithm, which covers front door. The reason for that is that because of this determinism, but I'm sure they want to generalize it to these settings because they do that with that mediation estimates too. So I wouldn't be surprised if it comes in some of these results. Yeah.
Are there any more questions in the room?
There are no questions online.
Feel free to unmute yourself if you have questions online. Yes, Steve?
Hi, I think I did write a question online, but Matt, thanks for the talk. I'm particularly interested in the last part of the talk where you talked about estimands.
Yeah.
Maybe a characterization of causal inference is that, you can say, here is the quantity that I want to estimate. Now, what assumptions do I need to make to estimate it? Rather than saying, here are the assumptions that I think are reasonable. What does this allow me to estimate? And would you rather have an unreliable estimate to the question that you want to answer, or a reliable estimate to a question which is somehow adjacent to the question that you really want to answer? Would be interested to hear your thoughts.
I would like the first thing. This goes back to the...
You'd rather an unreliable estimate to the right question?
Yeah, I think so. Or maybe, I don't know really what unreliable is, but I'm very open to admit that we don't have point identification, for example, and then do bounds or sensitivity analysis to the right question. I think that's how I philosophically am most inclined.
Interesting.
On the other hand, if we have a very precise question to answer to another question, this is the classical Tukey quote, I think, right? That better to have the approximate answer to the right question than the right answer to the approximate questions. Yeah, that's my take. On the other hand, I'm not saying it's bad to report other parameters that can be identified and we can study nicely. But then we could also think about how can that other parameter be formally related to the parameter of interest, and that.
Any other questions online? In the room? Well, if not, I guess let's thank again, Matt, for the very nice talk.
Thank you.